Assalamu alaikum. So the lesson today is about quadratic factoring. So we are going to learn today how to factor a quadratic expression ax squared plus bx plus c using direct factoring. So the direct factoring in fact work only for a specific quadratic expression. So the only quadratic expression where the direct factoring work is the quadratic with the leading coefficient equal 1, that means a equal 1, or a is a common factor of b and c. So this is where we can use the direct factoring. So let me state this. So we are going to learn today uh, direct factoring. So the direct factoring method work only the direct factoring method works only on quadratic expression ax squared plus bx plus c, where a equal 1 or a is a common factor of b and c. So let me give you the example where the quadrat or the direct factoring work. So example, so those are the type where we use direct factoring. Either we have, for example, x squared minus 5x plus x, or 3x squared plus xx minus 24, where we can take 3 as a common factor. You see, which means that in fact, in general idea, what we do, we try to factor leading coefficient equals. In that case, I can use the concept of the direct factoring method. As we try to factor x squared plus bx plus c by making x squared plus bx plus c equal a product of a x plus qr. So on the case when a equal 1, because this is behind your direct factoring. So how x squared, which try to find p, and that we have x squared plus bx. And what is the condition of P and Q? The P and Q has two conditions. If I take the sum of p, we need to uh, satisfy with those two numbers. Keep looking for those numbers. How do I know if I'm gonna factor that quadratic or not? The quadratic, or not or not. Is there any way that I know ahead if I can use the direct factoring or not? So those two questions, which is I ask all time to myself, is okay, is there any way that I decide before I start working? Yes, there is a way. So to factor x squared plus bx plus c. So the first condition, first, the discriminant, which is b squared minus 4c, because a here equal to 1. The first condition, the discriminant must be positive. That's the first condition. The second condition, the discriminant, after you check it's positive, it must be perfect square. If you have those two conditions, then yes, you can use the direct factoring method. So to factor this using direct factoring, method, we need those two conditions. If those two conditions satisfy, then I can use the direct factoring. If it's not satisfied, then don't waste your time. You cannot use the direct factoring method to factor a quadratic expression that does not satisfy those two conditions. All right, so let's do an example to show you the idea how it works. So let's do the first example. So if I want to factor x squared plus 5x plus 6. So I want to factor this. That means I want to write down this as x plus p times x plus q. So that's the idea. First thing, let me find the discriminant. See what is my discriminant. Discriminant is b squared minus 4c. So it's going to be 25 squared minus 4 times 6. As I say, a is 1, so we don't have to state it here. So it's going to be 25 minus 24, which is 1, so it's positive. And 1 square is 1, which means a perfect square. So now I can use my direct factoring method. So what I do, I'm going to look for p plus q equal 5 and p times q equal 6. So I start always with the multiplication, see which two numbers time together give me 6. I have 1 times 6 give me 6, minus 1 times minus 6 give me 6, 2 times 3 give me 6, and minus 2 times minus 3 will give me 6. So now what I do now, after I find out all the product that give me 6, what I do, I add them. So I'm gonna add and see what I will get. So here will give me 7, this is minus 7, this is 5, this is minus 5. I'm looking for those two numbers. So what I do here, 3. So let's do as of example. So that quadratic expression plus 4x minus 6. So here I don't have a equal 1. So which means what I do, I take 2 as common factor because 2 is a common factor of 4 and 6. So it's going to be x squared plus 2x minus 3. Now I have here a equal 1. So I'm going to try to see if I can use the direct factoring or not. So let me find my discriminant. I'm going to do discriminant only for that expression. So it's going to be 2 squared minus 4 times minus 3. So it's going to be 4 plus 12, which is 16. This is positive, and 16 is a perfect square because it's 4 square. So I can use the direct factoring here. So I'm going to look for p plus q equal 2 and p times q equal minus 3. So the two number, if I add them together, is going to give me minus 3 is 1 and minus 3, and minus 1 times 3. So that's the only two. So what I do now, I add and see which one gives me 2. So this is giving me minus 2, and this is giving me 2. So this is my choice. So what I do next, I just factor this. So it's going to be x minus 1 times x plus 3. So, and this is the factor of that quadratic expression. So let's pick another example. So I want to factor x squared plus 3x minus 24. So let me find out my discriminant. So is b squared, which is 3 minus 4 times minus 24. So it's going to be 9 plus 96, which is 105. 105 is positive, but it's not perfect square. 105, not perfect square, which means I cannot use direct factoring to factor this. But let's see if I'm right or wrong. So let's see if my idea here work or not. So let me see if I can find out two numbers such that we have p plus q is 3, and p times q is 24. So let me board 24, sorry. So I have p plus q is 3, and p times q is minus 24. So let me see which number, if I add them together, give me minus 24. So I have 1 and minus 24, minus 1, 24, 2 minus 12, minus 2, 12, 3 minus 8, minus 3, 8, and 4 minus 6, and minus 4, 6. And I think that's all. So that's the only set of pairs that give me minus 24. So what I do next, let me see if I can get 3 here. I will add all. So here will give me minus 23. This is 23. This is minus 12. This is 12. This is minus 5. This is 5. This is minus 2. This is 2. And as you see, none of them is equal to 3. So which means we cannot use the direct factoring here. So we cannot factor x squared plus 3x minus 24 using direct factoring. But keep in mind that we can factor using other method, but we cannot use direct factoring to factor that type of quadratic expression. As you see here, this is an example that if uh, the determinant is not a perfect square, so we cannot factor. The idea uh, x squared minus 3x minus 4. So first let me find out my discriminant. So it's minus 3 squared minus 4 times minus 54, which is 9 plus 216, which is 225, which is positive, and 225 is a perfect square, which is 25, which is 15 square, I think. Yeah, is 15 square. Is 15 square. You see, it's a perfect square, so I can use the direct factoring. So I'm looking for x plus p times x plus q. So I know that p plus q is minus 3 and p times q is minus 54. So let me find out two numbers. When we time together give me minus 54. So we have 1 minus 54 minus 1 and 54. We have 2 minus 27 minus 2 27. We have 3 uh, 3 18, so minus 18 minus 3 18. Do we have 4? No. 5? No. 6, so we have 6 and minus 9 minus 9 and minus 6 and 9. What else? Alright, so those are the only pairs, so I'm gonna add those pairs. So what I will get here, I get minus 53, this is 53, this is minus 25, this is 25, this is minus 15, this is 15, and here is minus 3, and this is 3, so of course this one will work. Obviously guys, if you are good on addition, so you can figure out this in a short time. I just show the steps here, so you understand my point. So here I know that P is 6 and Q is minus 9, so I just need to substitute here and I got my answer. So this is the idea behind how to use direct factoring to factor a quadratic expression x squared plus bx plus c. So I hope that you understand the main idea behind the lesson and you understand the test you should take before you start factoring or doing the steps of the direct factorings. So I hope everything is clear, and please any comment that will help me to improve my way of teaching, so do so. It will help me a lot. Thank you very much, and assalamu alaikum.